Okay, hi everyone, welcome back to this video series in Windows Server 2016, clustering improvements in Windows Server 2016. Now that we understand what clustering is and have gotten our hands dirty in walking through the process of building our initial cluster, let's review some of the parts and pieces working with clustering that are brand new or improved in Windows Server 2016 operating system. Multi-site clustering. Can I configure failover clustering across subnets? In other words, if I have a primary data center and I also rent space from a colo down the road, or I have another data center across the country, there are options for me to set up clustering between nodes that are physically separate. There's a quick, easy answer here. Yes, failover clustering doesn't care just as easily if those server nodes were sitting right next to each other. Clustering can take advantage of multiple sites, each hosting their own clustered nodes and more services back and forth across these sites. Even better is that new in Windows Server 2016 is an organizational tool for managing multiple sites, giving you the ability to group cluster members together based on where they physically reside. This allows you to configure preferred sites rather than allowing the clustering mechanism to decide for itself. Cross-domain or workgroup clustering. Historically, we have only been able to establish failover clustering between nodes that were joined to the same domain. Windows Server 2016 brings the ability to move outside of this limitation, and we can even build a cluster without Active Directory being in the mix whatsoever. In Server 2016, you can, of course, still create clusters where all nodes are joined to the same domain. And we expect this will still be true for the majority of installations out there. However, if you have servers that are joined to different domains, you can now establish clustering between these nodes. Furthermore, member servers in a cluster can now be a member of a workgroup and don't even need to be joined to a domain at all. While this expands the available capabilities of failover clustering, it also comes with a couple of limitations. When using multi-domain or work group clusters, you will be limited to only PowerShell as your cluster management interface. If you are used to interacting with your clusters from one of the GUI tools, you will need to adjust your thinking cap on this. You also need to create a local user account that will be used by clustering and provision to it to each of the cluster nodes, and this user account needs to have administrative rights on those servers. Cluster operating system rolling update. This new capability given to us in 2016 has a bit of a strange name, but it is a really cool feature. It's something designed to help those who have been using failover clustering for a while to be able to improve their environment. If you are running a cluster currently and that cluster is in Windows Server 2012 or 2, this is definitely something to look into. Cluster operating rolling upgrades enables you to upgrade the operating systems of your cluster nodes from Server 2012 or 2 up to Windows up to Server 2016 without downtime. No need to stop any of the services on your Hyper-V or scale out file server workloads that are using clustering. You simply utilize this rolling upgrade process, and in the end, all of your cluster nodes are running the new Windows Server 2016. The cluster is still active and nobody knows that it ever happened. This is vastly different to the previous upgrade process, where in order to bring your cluster up to Server 2012 or 2, it required taking the cluster offline, introducing new server nodes running 2012 or 2, and then re-establishing the cluster. There are plenty of downtime and plenty of headache in making sure that it all went as smoothly as possible. The trick that makes this seamless upgrade possible is that the cluster itself remains running, and at the 2012 R2 functional level until you issue a command to flip it over to the server 2016 functional level. Until you issue that command, clustering runs on an older FL, even on the new nodes that you introduce, which are running server 2016 operating system. As you upgrade your nodes one at a time, the other nodes that are still active in the cluster remain online and continue servicing the users and applications, so all systems are running like normal from a workload perspective. As you introduce new server 2016 boxes into the cluster, they start servicing workloads like 2012 R2 servers, but are doing so at a 2012 R2 function level. This is referred to as mixed mode. This enables you to take down even that very last 2012 R2 box, change it over to 2016 and reintroduce it all without anybody knowing. Then once all of the OS upgrades are complete, issue the PowerShell commands, update cluster functional level to flip over the functional level, and you have a Windows Server 2016 cluster that has been seamlessly upgraded with zero downtime. Virtual machine resiliency. As you can successfully imply from the name, virtual machine resiliency is an improvement in clustering that specifically benefits Hyper-V server clusters. In the clustering days of server 2012 R2, it wasn't uncommon to have some intra-array or intra-cluster communication problems. This sometimes represented itself in a transient failure, meaning that the cluster, though a node was going offline when it actually wasn't, and would set into motion a failover that sometimes caused more downtime than if the recognition patterns for a real failure would have simply been a little bit better. While for the most part, clustering and failover of cluster nodes did work successfully, there are always room for improvement. That is what virtual machine resiliency is all about. You can now configure options for resiliency, giving you the ability to more specifically define what behavior your nodes will take during cluster node failures. You can define things such as resiliency level, which tells the cluster how to handle failures. You can also set your own resiliency period, the amount of time that VMs are allowed to run in an isolated state. Another change that is unhealthy: cluster nodes are now placed into quarantine for an admin-defined amount of time. They are not allowed to join back into the cluster until they have been identified as healthy and have waited out their time period, preventing situations such as a node that was struck in a reboot cycle from inadvertently joining back into the cluster and causing continuous problems as it cycles up and down. Storage replica. Storage replica SR is a new way to synchronize data between servers. It is a data replication technology that provides the ability for block level data replication between servers, even across different physical sites. Storage replica itself is a new form of redundancy in Windows Server 2016 that we haven't seen before in the Microsoft world. We had to rely on third-party tools for this kind of capability in the past. Storage replica is also important to discuss right on the heels of failover clustering, because SR is a secret sauce that enables multi-site failover clustering to happen. When you want to host cluster nodes in multiple physical locations, you need a way to make sure that the data used by those cluster nodes is synced continuously so that a failover is actually possible. This data flow is provided by storage replica. There are three different ways that you can accomplish storage replica. Here's a summary of each that you can decide what works best in your environment. Stretch cluster. The storage replica stretch cluster is just like the name implies, stretching a single cluster across multiple sites. The best real-world case of this that I can think of is a Hyper-V cluster. Think about Hyper-V environments being replicated to a disaster recovery site, always staying instantly up to date and being immediately available in the event that your main site disappears. Stretch cluster features auto failover capabilities and asynchronous replication. Cluster to cluster. Here we have a slightly different take for a different use case, cluster to cluster. This is the scenario where you would have to have a cluster in your main data center that is being replicated to another cluster that exists in your DR site, server to server. Even if you aren't a cluster administrator, this one should pique your interest. The server to server mode of storage replica can be used as a powerful tool for data replication. Think of it as your new file backup solution. You can have two separate servers running in two sites, and storage replica will keep their data identically replicated at all times. It is important to note that server to server mode involves a manual failover in the event that a site goes down. But if synchronization for small use cases, perhaps a small business has a single file server and doesn't yet have the budget to implement another server, wants to keep a backup copy of their data on the same server where it has been hosted from. One of the neat data points about storage replica is that it finally allows a single vendor solution, that vendor being Microsoft, of course, to provide the end-to-end technology and software for storage and clustering. It is also hardware agnostic, giving you the ability to utilize your own preference for the storage media. Additionally, since the storage is block level, it doesn't matter what type of file system you're running, and it doesn't matter whether or not the files are currently in use. They will all be replicated as exact matches. Microsoft is touting zero pro replication, guaranteeing that you will not lose data. Storage replica is meant to be tightly integrated as one of the supporting technologies of a solid failover cluster environment. In fact, the graphical management interface for storage replica is located inside the failover cluster manager software, but is of course also configurable via PowerShell. So make sure that you take a look into failover clustering and storage replica as a better together story for your environment. Storage Spaces Direct. There is another new offering inside Windows Server 2016 related to storage and clustering, and this one will be very important to anyone with large data storage needs. We have had the ability to do scale out file servers for a few years now, but providing a Windows Server front end that taps into a large disk space back end has typically required some vendor participation with regard to the back end. We most commonly set up some kind of shared SAS backend, typically involving an expensive SEN controller and some kind of JBOD enclosure that stores all of our SAS disks. Well, you can now take everything that you know and have spent the last number of years learning about how to make this SAS system work like you want it to and throw it all out the window. Storage Spaces Direct is a technology running right inside Windows Server 2016 that takes the idea of stored spaces on a single server and expands that mentality across multiple servers. Let's say you have 2 servers or 3 or 4 and so on, and each of those servers has multiple hard disk drives inside it. This drives can be anything. They can be high performance SAS disks, or they can be simple SATA drives that you had laying around. Using either PowerShell or System Center, you can cluster these servers together, configure storage spaces direct, and then create pools of storage, create pools of data that shares space among all of the hard drives that are plugged into all of the servers. Storage Spaces Direct is really the flagship of Microsoft's new software-defined storage mentality, and they expect it to be used heavily in the years to come. To me, one of the neatest parts of Storage Spaces Direct is down the road, after you have been using it for a while and suddenly realized you are running out of space and need to add some additional storage. What to do? Simply create a new server, throw some drives in it, and run a simple PowerShell command and add the new server into the cluster. The existing cluster is extended to include the new server, and storage pool and volumes you have created start expanding automatically. Summary: redundancy is a critical component to the way that we plan the infrastructure and build servers in today's world. Windows Server 2016 has some powerful capabilities built right into that you can utilize in your own environment starting today. I hope that by gleaning a little more information about network load balancing and about failover clustering, that you will be able to expand the capabilities of your organization by employing these techniques and stretching the limits of your service uptime. In my opinion, if there is any one avenue out of this chapter for you to pursue, it is the utilization of failover clustering in order to make your virtual machines redundant among multiple Hyper-V servers. This is such a powerful enhancement to a virtual server infrastructure. It will likely change the way that you work and give you some peace of mind, and that you didn't think was possible in a world aiming for 99.999% uptime. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.